Okay, by names of Mwize Daniel, Mara University of Science and Technology, doing BCS, Computer Science. This is course unit database and management system, course code CSC1204, reg number 2024 BCS 035 PS, student number 240060 3485, name Mwize Daniel. So this is my database project report. So first of all, executive summary. This is summary that will show roughly that will show what the project is all about. It is about banking. It is a banking database management system. This project presents the development of a customer account management system for a banking institution. The objective is to design, implement, and test relational database that manages and tracks customer information, account types, financial transactions, and employee responsibilities efficiently. The database is implemented using MySQL, where the user relational database management system. It comprises multiple interrelated tables for customers, account, employees, and transactions. The project walks through a full cycle of database development, requirement analysis, logical and physical design. Implementation, sample data insertion, testing through meaningful queries. This report is intended to showcase the students' ability to understand and practically apply the concepts of database management system in real-world context. And first of all, go to business case application domain. The customer account management system developed in this project supports essential operations in banking institutions, and these operations include registration and management of customer data such as personal details and contact information. Number two, creation and tracking bank accounts including savings, checking, and loan accounts. Number three, recording and management of banking transactions such as deposits, withdrawals, transfers, etc. Number four, employee interactions with customer data, enabling support, query resolution, and account management. Number five, the system serves multiple user groups, including bank customers, bank employees, such as traders, managers. The system administrator, e.g., has a defined role in accessing and management the data in the system. So we go to benefits. The benefits of my database, there are tangible benefits and intangible benefits. So about the tangible benefits, efficiently automates manual processes, reducing the time required to handle customer requests. Account number two, minimize accuracy. Minimizes human error in financial transactions data entry. Number three, centralization. About centralization, the details about it offers a single and a field database for storing all banking data. Security provides controlled access through role in data validation. About the intangible ones, we have customer trust, employee satisfaction, data insights, and the explanations as shown there. And we'll go to cost analysis. There are tangible and intangible costs. So about the tangible costs, we have hardware infrastructure, costs related to servers, network setup, and computer software tools, use of MySQL, free but professional tools like MySQL Workbench may be required, like it requires licensing. Human resources, costs for developers, database administrators, and traders. About the intangible, training time, data migration, change management, so on. About user issues and risk assessment. User issues, staff with limited technical skills may find initial usage challenging. Users need clear and intuitive interfaces for each operation. Training programs and user manuals are needed to ensure smooth adoption. About risk assessment, technical skills, server downtime, SQL injection attacks, data corruption, those are risks that can expect. Organizational risks, budget overrun, scope creep, staff rejection, then the legal risks and system limitations, though it has some good, but it has the positive side of it, but it also has the negative side of it. Right now, there are things that it can't do. So currently, there is no web or mobile banking interface, no integration with ATM services and third-party financial APIs, limited data analysis and report generation features, no multi-language support. So another one, it has entities and attributes, as you know. So about the entities, we have customer, account, transaction, employees, and the attributes of these entities. About customer, with customer ID as the primary key, name, address, phone, email. About account, we have account ID as the primary key, customer ID, which is their foreign key, account type, balance, and open date. Then about the transaction of transaction ID, which is the primary key, account ID, which is the foreign type, account, date. Employee, we have employee ID, which is the primary key, name, position, and branch. So that's those are my attributes and entities. About the physical design, I used MySQL. These are the codes I used. Design it. I first created a table for customer with the customer ID name and so on as I told you in the entities and attributes. I put the attributes for it there. Then I created another table which is for account as with the account ID as the primary key. And put the attributes there and down that's the foreign key which is customer ID. So another one, created another table which is the third one. My tables are just four. Created four tables: account, it is account, customer, transaction, and employee. So this is the transaction one with the transaction ID as the primary key and the foreign key as the account ID. And I created the last table which is employee with the employee ID as the primary key. And that was my physical design of the code of the database. Then about relationships, one to many, one customer can own many accounts. One to many also, one customer can have many transactions. Also one to many, one employee can manage multiple customers abstracted through record or log management. So data insertion commands. So these are my data insertion commands. I first inserted insert for the employee data. Employee data, those were my insertions as shown. And about customer, those were insertions as shown in the that should appear in the table. If it is the date, then the date. If it is account ID, which account. If it is the name, which name. Those are the sample of the names I used, like the insertion commands I used. So that is the account data also, and that is the transaction data. It's about my integration diagram. This is it. It has customer ID, which is the primary key there. Customer ID leading you to account ID for transaction as shown in that ER diagram. I think it is not so much hard to understand. It is self-explanatory. So these were my results as the sample screenshots of after putting my code in MySQL. This was the sample of the output. So this was before I put the insertion commands. So this is the first table. This one is the first table for employee. Yeah, for employee. This is the second table for customer. Then after that, this is the third table for account, then the fourth table for transaction. So that's it. And after putting the insertion commands, like feeding the tables, this was my first output about the account. That is what came out. Then about the employee, that was my output of the employee. And about the customer ID also, that was my customer with the name, address, phone, email, employee ID, and so on. Then about the transaction, so that one that was that was the output of what I put in my tables: account ID, type, month, date, and so on. So I have these others is like includes